Figure 1 shows the design for a tabletop in the shape of a rectangle ABCD, and the length of the table AB is 1.2 is shown, and the area inside the closed curve is made of glass, and then the surrounding area of wood. And the perimeter of the glass is modeled by this polar equation. Cool. Where A is a constant. We're asked to show that A is 0.2. Well, they haven't actually shown us where the origin is here, or where the initial line is or anything, but because of the symmetry of cos, I think we can kind of just go and say it's in the middle. But that is, it does end up being there, and you can kind of play around with the numbers and you'll see that is true. So that means, all right, if I now draw my initial line, okay, so we see that this is when theta is 0, and we're going to get r as 0.6 there. Because remember, with our polar system, this is 0, and then we imagine like moving around until we've gone 2 pi. So all I can do is just sub in 0.6. It's going to be 0.6 plus 0.4 plus a times cos of 0, which is just 1. So therefore a is 0.2. So you can't get that or whatever, just put it in and you can still get 8 marks coming up. We're asked to find the area of the wooden part of the tabletop, giving our answer in meters squared to 3 significant figures. Right, so what we're going to need to do here is integrate our polar equation to work out the glass, and then we're going to subtract it from the area of the rectangle. Okay, but it's all about the glass, really. So we want to basically integrate around the angle, and what we are doing is we've got this just imagine we've got a small sector here. I always like to derive the equation. Now, if you want to find the area of the sector, it would be a half r squared d theta for this really small angle. But then just imagine we're summing up all of these like little instantaneous sectors. That's when we put the integral sign. And that's going to be our area. And we're going all the way around. So we're going between 0 and 2 pi. Okay, let's get into it. So area of glass is then going to be equal to, I can bring out the half, 0, 2 pi, and I'm going to sub in for our r, 0.4 plus 0.2 cos theta all squared. Amazing. Zero 0.16, then 0.4 times 0.2 is 0.08, double it because there's two of them. We're going to get 0.16 again, cos, there should have been a 2 theta there, apologies, plus 0.04 cos squared 2 theta. Okay, there's something you can do now, which is just going to save a little bit of time. And I don't think the mark scheme mentions it, but I feel like it should be valid. Now, if you integrate cos theta, or sine theta, in fact, between 0 and 2 pi, or actually over any of its, as long as you're going over a period of 2 pi, you'll always get 0 because the positive part will cancel out with the negative part. And if you make it so it's 2 theta, all you're doing is stretching it by a scale factor of a half and fitting two of them in. But what I'm trying to say is this is just going to equal 0, and I could just write it down straight away. If you don't spot it, you're just going to integrate, you're going to get sine 2 theta, some multiple of, and when you put in 0 and 2 pi, you're going to get 0 there. But we can just get rid of it. Okay, now to integrate cos squared. This is like one that you just see so many times in further maths especially, but also quite often in maths A level. Double angle formulae. Cos 2a. I know it's cos 2a already, but we'll worry about that in a minute. That is identical to cos squared a minus sine squared a. And what I can do is replace sine squared by 1 minus cos squared and get 2 cos squared a minus 1. Then cos squared a is going to become a half plus a half cos 2a. Okay, so therefore cos squared 2a, because that's actually what we want, is going to be identical to a half plus a half cos 4a. And that is what I can put in here. So my next line is going to be a half integral 0 to 2 pi 0.16 plus, and what I'm doing is putting this in here, so it's going to be a half of 0.04, which is 0.02, and then plus 0.02 times cos of 4 theta. The thing is, just like I cancelled out the cos 2 theta, it's exactly the same. It's just now I've got like 4 lots of cos over this interval from 0 to 2 pi. This is going to be 0 again. Again, if you, I mean, maybe if you have time, you could come back and just like show where it comes from using integration, but I feel like absolutely valid. And if I draw, I think it's fine. Because suddenly the integral becomes really simple. It's just the integral of 0.18, which is then going to give, well, it's 0.09 if I times by a half, then times by theta, evaluated between 0 and 2 pi. So actually we're back to 0.18 pi, which we can then, well, we could write it as, I think I wrote it as 9/50, but I'm just going to leave it exact for the moment. So that is the area of the glass. Okay, so then the area of the table was 1.2. That was the length. And we're told here that AD is 60. So in meters, that's going to be 0.6. So 1.2 times 0.6, which is 0.72. And we're one step away. So the area of wood is 0.72 minus 0.18 pi, which is 0.1545 or 0.155 meters squared. Okay, yeah, good question. Well done.